Hello friends, welcome back to my classroom. In this video, let us discuss about exponential distribution. The probability distribution having the probability density function as lambda e power minus lambda x whenever x is non-negative and 0 otherwise. It is called as exponential distribution. So lambda is called as parameter here. So lambda multiplied by e power minus lambda x whenever x is positive. So in this case, if probability distribution has this as the PDF, this function has the PDF, then it is called as exponential distribution. So it's very easy to show that this exponential distribution is valid probability density function, as we have discussed already. Whenever the integration is equal to 1 and of course f of x non-negative, if this is equal to 1, it's a valid probability density function. That very easily we can check lambda e power minus lambda x, and if we integrate 0 to infinity, because minus infinity to 0, it is 0. And it's a very simple integration. Lambda is a constant that can be taken out, and e to the power minus lambda x we need to integrate, which is e power minus lambda x divided by minus lambda, and 0 to infinity. So lambda you can cut, and after cutting lambdas you can apply the limits. Upper limit is infinity, so in place of x you are writing infinity, and minus of one more minus is there, so of course here minus was there. Minus of minus is plus, e to the power minus lambda into 0, which is 0. So e power minus infinity, this will be infinity minus infinity, so this will be 0, plus e power 0, any number power 0 is 1, so this is 1, 0 plus 1 is 1. So this is a valid probability density function. And if you find the mean of this, the mean is going to be 1 divided by lambda. That means if mean is 3, lambda will be 1 by 3. And if lambda is 5, mean will be 1 by 5. So they are reciprocal of each other, mean and lambda. Okay. And if you find the variance, variance is going to be 1 divided by lambda square. So for example, if mean is 3, you know that lambda is 1 by 3. Okay. If lambda is 5, let us take, you know that mean is 1 by 5, but variance will be 1 divided by 25, because it's 1 by lambda square. And standard deviation is again square root of variance. Square root of variance, it will come back to 1 by 5 only. So in case of exponential distribution, mean will be 1 by lambda, and also standard deviation also is 1 by lambda. Okay, and only the variance will be 1 divided by lambda square. Now let us take some of the problems, okay, to understand in what situations you can apply exponential distribution. So as I have already mentioned, the exponential distribution is often used for to model the time elapsed between two successive events. So here let us take this example. The length of a telephone conversation has an exponential distribution with mean of 3. Find the probability that a call ends in less than 3 minutes or it takes between 3 and 5 minutes. So what is given here, on an average, the telephone conversation, whenever telephone conversation happens, it is on an average it is 3 minutes. Average mean is 3 minutes. And suppose there is a call, okay, going on. So what is the probability that that call will end in 3 minutes? Okay, it will not go beyond 3 minutes. Alright, it will end within 3 minutes. That's our first question. So we know that our probability density function is lambda e to the power minus lambda x for non-negative x's. So I'll not say again and again. It's the exponential distribution is starts from 0. Okay, below 0 the value is 0, so we can ignore it. So we will talk only from 0 to infinity. So p of x is lambda e power minus lambda x. So in this question, mean is given as 3. Mean is 3. So lambda is going to be 1 divided by 3. This we have already discussed. Lambda is equal to 1 by mean and mean is equal to 1 by lambda. They are reciprocal of each other. Now I need to find the probability that I'll take yeah, I need to find the probability that x is less than 3. It ends in 3 minutes. So the probability that a call ends in 3 minutes. So within 3 minutes means it has to be less than 3 minutes. So from where to where? From 0 minutes we start and up to 3 minutes I need to integrate. What function I need to integrate? Lambda e power minus lambda x. And whenever you integrate lambda e power minus lambda x, lambda will be constant and e power minus lambda x divided by minus lambda. And minus lambda gets cancelled. The integration value will be e power minus lambda x. So lambda e power minus lambda x, whenever you integrate, it's going to be minus e power minus lambda x. And limit is from 0 to 3. So what will happen? I'll apply the upper limit. Upper limit is 3. So it will be minus 3 lambda. And minus of minus plus. Whenever you apply a lower limit, it will be minus of minus. So it is plus. So for upper limit it will be negative, for lower limit it will be positive. E to the power 0 is the lower limit. So 0 into anything is 0. And after that you can substitute the value of lambda also. This lambda also we know now. Okay. So lambda also we can substitute. What is lambda? Lambda is 1 by 3. So first of all 3 is there. So 3 I'll write into lambda also is it's 1 by 3 plus e power 0 is 1. So this is e power minus 3. I mean 3 and 3 gets cancelled. You will be having e power minus 1 plus 1. And you can use your calculator to find the final value of this. And this value is going to be 0.6321. Okay. So the 0.6321 is the probability. That means 63% chance is there that the call will end in 3 minutes. Okay. So similarly, we can check what is the probability that it will, call will be between 3 and 5 minutes. So what you have to do, call is between 3 and 5 minutes means you just have to integrate the function, but this time limit is from 3 to 5 minutes. So 3 to 5 minutes I am integrating the probability function, which is lambda e power minus lambda x, and as already I have discussed, this integration is going to be minus e power minus lambda x, and the limit is from 3 to 5. So the limit is 3 to 5. I'll apply the limit minus e power minus, in place of x I am putting 5, so it's 5 lambda plus e power minus, this time I am putting 3, so it will be 3 lambda. And after that you can substitute the values of lambda also, minus 5 divided by 3, because 1 by 3 is the lambda value, and e power minus 3 divided by 3. Okay, which is, after your calculation, I have written the value here. Your final value will be 0.179. So 0.179 will be the probability that the call will be more than 3 minutes and less than 5 minutes. Okay. So I'll give a similar example. In a certain town, the duration of a shower is exponentially distributed with a mean of 5. So what is the x here? X is duration of shower. Duration of shower. And what is the mean? Mean is given as 5 minutes. So that means lambda will be 1 divided by 5. Now you can take the value questions one by one. Less than 5 minutes. So the probability that x is less than, 10 minutes, less than 10 minutes. X is less than 10. So 0 to 10 you will integrate lambda e power minus lambda x, which will be negative e power minus lambda x, and limit is from 0 to 10. So this is minus e power minus 10 lambda plus e power, lower limit is 0. So this will be 0. E power minus 10 lambda plus e power 0. When you calculate this, you will be getting 0.8647. So you can use your scientific calculator for the calculations. So the final probability will be 0.8647. And second question is more than 10 minutes. Of course, you can integrate from 10 to infinity if you want. Okay, that will give you the probability of more than 10 minutes, or you can use the concept of complement. Less than 10 minutes, complement is more than 10 minutes. So the probability that x more than 10 is 1 minus probability of x less than 10 minutes. So what will happen? Of course, you might have got some doubt why it is not less than or equal to. In discrete case, this less than or equal to matters, but in continuous case, less than you can use or less than or equal to. It's one and the same. Okay, that doesn't make any difference. So x greater than 10 is complement of 1 minus, complement of x less than 10. Yes, x less than 10 already we have calculated. So it will be 1 minus 8647, which will give you the value 0.1353. Okay. Here I will give one more example because you should not be in a hurry to write down the value of the mean, but you have to think what is the mean given here. So in a certain bus stop, 3 buses arrive. So you might be sometimes uh, suddenly you might think that 3 buses means 3 will be the average. Okay, but here the random variable is different. It is not the number of buses. Okay, 3 buses arrive per hour on an average. Assuming that the time between successive arrival is exponentially distributed. So x is not number of buses here. It is the time between 2 successive buses. Okay, 2 successive buses. So x is time between 2 successive buses. So 3 buses in 1 hour. That means 20 minutes will be the time between 2 buses. Total is 60 hours, 60 minutes. 3 buses are coming. So every 20 minutes you are getting a bus. So here mean is 20 minutes, which means lambda is 1 divided by 20. So rest all you can do very easily. Probability of x less than 10 means x less than 10 means you can integrate 0 to 10 lambda e power minus lambda x, and lambda you can put the value 1 by 20 after integrations. So you will get minus e power minus lambda x 0 to 10 and minus e power minus 10 lambda, 10 into lambda, lambda is 1 by 20 plus e power 0, which is minus e power 1 by 2, which is 0.5 plus e power 0 is 1. So that will give you the value 0.393. Okay. The other one I'll leave it to you. It is just the integration of the same thing, but integration is from 30 to infinity. Okay, 30 to infinity p of x dx. So when you integrate this, you will get 0.2231 as your answer. Okay, you can cross check this. Okay, so exponential distribution is a very simpler one, where probability density function is lambda e power minus lambda x for non-negative x and 0 for negative x. Okay, so other things you know how to evaluate the probabilities. So if a to b you need the probability, you just have to integrate between a and b. Okay, so in the next class what we will do is we will we have covered already the exponential distribution. So in the next class we will discuss normal distribution. Okay, so thank you.